everyone, welcome to our lesson on stretching, shrinking, and reflecting the graph of f of x equals x to the nth power. We're going to look at some power functions and talk about what causes those stretches and shrinks and reflections. So to know if your function has had a stretch or a shrink, what you're going to look for is the coefficient in front of the power. So if you see that you have a number there whose absolute value is greater than 1, like an integer, a positive or negative integer, that's going to cause a stretch in your graph. But if you see that you have a fraction there, some number that the absolute value is less than 1, then that's going to cause a shrink in your graph. So I'll show you visually sort of what those look like in just a minute. So here are the algebraic examples. So if you see, for instance, a 3 in front of your cubic or power 4, power 5 function, that's a stretch, okay? Negative 4 is also another stretch. Positive or negative numbers don't matter here as long as the absolute value is bigger than 1. Down here at the bottom, you can see some examples of shrinks. If you see a fraction, that's going to be a shrink as long as that absolute value is less than 1. The negatives are going to come in and cause reflections. That's what those do. So these second examples here in each category have had a reflection on the graph. All right, so visually, what does that look like? So let's take a even powered function, for instance, and see what that looks like. The parent graph of a regular x squared or x to the 4th function would look something like this. If it's been stretched, it's going to be pulled closer into the y-axis, something like that. It's just going to, you can picture pulling it up from the top and stretching it longer. And if a shrink has been applied, it's going to look wider, like it is shrinking towards the x-axis. It's being compressed from the top. You can think about it that way. Now that's an even powered function. Let's take a look at an odd powered function, something that's doing different things on both ends. There's a parent graph, for instance, of maybe an x to the 3rd power, and when that's stretched, it's going to look like it's being pulled from both ends, getting longer towards the y-axis. So it may be, we're not sure until we see our coefficient how much of a stretch that we've had, but it's going to be definitely some amount closer to the y-axis. So there's maybe a stretch for a cubic function, and then as we have a shrink in those, we're going to get closer and closer to the x-axis, kind of like it's being pushed down from both ends, so a little bit wider. All right, we talked about earlier that negative in front causes reflections around the x-axis. So for an even powered function, again, let's take a look at evens up here. For an even power, if it's starting off in the upward direction and it's been reflected, and it's going to be flipped downward. And if we have a odd powered function like a cubic, if it has been turned over the x direction, something like that, if you can picture that, it's going to look something like this. So turning it in the x direction is going to make that this left hand down end move upward, and then the right move down. All right, so how do we graph these? Well, there's a lot that is involved with this. To get a really, really accurate picture, we would need to go in and find all the zeros, all the places where it's crossing the x-axis. But we're just going to get a general idea of the picture on this one. What you can do is you can test a couple of points, a couple of x values, and find the matching y's. And you can be aware of the end behavior, and you can get a pretty good picture that way. So we've got negative 2x to the 4th. Now we do know that this little negative in front is going to cause a reflection, because we talked about that. And we do know that this 2 is going to cause a stretch. So how much of a stretch? Well, let's test a couple of values over here in a little table. Let's make an XY chart. So let's test some easy numbers. Let's try 0, let's try 1, and -1. Those are always good numbers to test because we'll get a nice even picture, or something positive and something on the negative side. And then we can move up and also test 2 and negative 2. All right, so when you plug in a 0, you're going to have a 0 come out. 0 to the 4th times 2, still 0. We test our 1, we're going to end up getting negative 2. Okay. If we test a negative 1, we're going to get the same thing. And then once we get a little bit past that, it's going to start getting very, very large, the numbers. Plug in a 2. You may have a calculator. You may be doing this manually. It's going to get negative 32, okay, for both that 2 and negative 2. Fit that in there. All right, so just to get a general picture here, we can plot some of these points here, and we know that for even-powered functions that the ends are doing the same thing. The end behavior should both be doing the same thing. And since it's been reflected, they're both going to be going down instead of up where they started in the original parent function. So this graph may look something like this, because it's going to shoot way down once we get out past that, those 1s and negative 1s. Something like this. So that just gives us a general picture. This concludes our lesson on stretching, shrinking, and reflecting the graph of f of x equals x to the n.